Okay, so today we're going to do lesson 5-4. So make sure that you pass up your 5-3, and I'll give you a second to do that. Make sure that you've cleared your memory on your calculator, and I'm showing this again because I hit the video record. So on the calculator, you're going to turn your power on. If it's inside something, you can quit out of it by going second function quit, and then you can clear your screen to clear it, but you still need to clear your memory. So to clear the memory, you hit second function, and then you go down to memory, and then we're just going to type the numbers. So we're trying to reset the RAM. So it's 7, and then 1, all RAM, and then 2 for reset. Okay, and then you'll get the message RAM cleared. Okay, and then I'm going to clear that off my screen. Okay, so what I want to do is show how to graph systems of equations and find intersection points. And here they gave us two, a quadratic and a cubic to graph. So let's graph these and look for their intersection points. Those would be the solutions of that system. So they told us graph y1, what we have, actually let me back up. What are the real solutions of the equation x cubed plus 5 equals 4x squared plus x? So what you're going to do is you're going to set y1 equal to the first equation and y2 equal to the second equation, and then you're going to graph them both. So that's what we're going to do now. So get your calculator, make sure your memory's cleared, and hit your y equals button right up here. Y equals. Now what we want to put into y1, if there's something typed there, you didn't clear your RAM. Make sure you cleared your RAM. Now for y1, we're going to type in the first equation, x cubed plus 5. Now remember, to do a variable, you have to use the variable button. It's to the right of the alpha. So notice when you just click that, it gives us the first variable, x. Now we want to make x cubed, so you have to do the caret sign here, which is right under your clear button. It looks like a little rooftop. And then 3. So that x caret 3 means x to the third power. That's how we display that in this calculator. Okay, so we've got x cubed. Now we have to do plus 5. So add plus 5. And press enter. So there's your first one, x cubed plus 5. And our second one is 4x squared plus x. So let's type that in. 4x squared, so I'm going to do the caret 2, 4x squared plus x. Now I'm going to press enter. I've got both equations entered. And I'm going to hit my graph button on the very right hand side. Now we're going to look first at what happens. So we got the cubic graph, and then we got the quadratic graph, the parabola. So if you did it y1, y2 like we did it, that should be the order it graphed in. And we want to look for the intersection points. And this is pretty small, and nothing's really labeled specifically, so we have to calculate these intersection points. So to do that, and I also want to reiterate again that the intersection points are your solutions to these systems of equations. Okay? These just happen to be cubics and quadratics, right? We did this a lot in Algebra 1 with linear systems, right? Y equals mx plus b, slope intercept. We did all those. But now we're doing it with our cubics and quadratics. So let's figure out how to get the intersection point. You're going to click calculate, so second function, trace. And we want to find the intersection points, and that's number 5. So press 5. So we're calculating intersection. So what we have to do is tell it which curve are we looking. I'm going to go to the left. So I'm going to use my right arrow to come over left. And it's going down, down, down. I'm below that first intersection because I want to see, I've got more than one intersection here. I want to see this first one on the left side. So I'm going to go below it and press enter. And now notice that the cursor popped right back up to the parabola. So it recognizes that's the second graph. So we'll accept that. Enter. And guess, just press enter again. And it's calculating. You'll know it's calculating because you'll see the running little ribbon over here. The cursor just moving and rolling around up here in the right hand corner. Now it tells us our intersection is x equal -1.093763 and y equals 3.6915105. So there's our first point. Now I want you to calculate the other. And actually if you were to zoom in on this, you would see there's two more intersection points because this parabola and the other graph weaves in and out twice. And let me show you. Oh, I don't have it on this. This is just something I copied. Oh, actually, here it is. Right here in the right-hand corner, you can see that this has several intersection points. Here's one, and there's one. So just on the right side, there's two intersection points. So be careful. You sometimes have to zoom in to see, oh, I've got several intersection points. But for the sake of this assignment, we'll use the bottom one on the right. So let's calculate the next one. So to do the next intersection point, we want to get on the other side. You're going to have to do this again. So go second function, calculate, and intersect. And now we've got to move our cursor over to the other. So I'm going to go in front of that intersection point and press enter. And now I'm going to go outside. Now, so I think it will still find that particular intersection just being close to it on the parabola. So I'm just going to press enter and see what flies. And it did. Okay, so it shows us by the blinking cursor where the intersection's at. And it gives us there it is. The x-intersect on the right-hand side, right up there, is 1.1629619, and y is equal to 6.572883. Now, for your homework, unless if they tell you to write 6 decimal places or however many that is, you can round to 2 decimal places. So you could do 6.57, or you could do 6.6, and I would still give that to you. All right. Any questions on how to find intersections and how to use this? You'll get this on your test. So even when it's not asking you to use a graphing calculator, it sure will benefit you in other ways if you know how to calculate these and find graphs and create your graphs, which you've now done. Any questions? All right, so if you will turn your calculator off, first just hit clear and exit. So quit, which is second function, quit, and then power it off, which notice that off is in yellow down here, so you have to press second function, the yellow button, and then hit the on button, which is actually off now. And close it, and let's put them back up. And I'm going to pause the video. So, back to the lesson. Remember that I gave you links to get these, and I gave you also another graphing calculator link called Desmos, which is a really cool thing. It's not like your school one, but it's still a really good tool. All right, so let's move on with our assignment. So today we're going to do 5.4, and it's talking about using polynomials for long division. And again, this is nothing more than Algebra 1 review. Okay, heads up, please. Everybody should have their notes out. Everybody should be facing forward. Same too. Every day you should have your notes out. We are at the end of the semester. What are you thinking? if you want to put your head down, because you're sick, I'm not griping at you. All right. This says using polynomials for long division. And this is part of how you're going to start your poster over the weekend. If you're going to get an equation like this, 4x squared plus 23x minus 16. And they say divide this by x plus 5. What is the quotient and the remainder? And you've got a lot of busy work for your homework tonight. It's just division, 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 division. But we're dividing big things now with variables instead of small numbers like 45 into 10,043, like you did in 5th grade. Now we're adding variables to it. By a show of hands, who did this in Algebra 1? And you did it like this, the long division. With variables?
No.
Okay, yeah, you should have, everyone should have done elementary, but who's done it with the variables? It was an Algebra 1 thing. So, that's a 0. That was 0 hands. It was one student, she was my previous student, the only one that raised her hand first hour. It's like, I know I taught it. You were supposed to have learned this, so we're going to have a tough time getting through the lesson today because I've got to reteach this. So let's do a quick learning process here, and let me go to a new screen. So when you have long division, this is how you're going to write it with polynomials. Okay, if you're missing, every power has to be accounted for. So notice that this is my x squared column, right? This is my x column, and this is my, oops. This is my x to the 0, so that's like x to the first power, and this is like x to the 0 power, right? So if you are missing like an x term, you would put a placeholder in there like 0x. Or if you didn't have that constant on the end, you could just do a plus 0. Okay, so if you're missing a term, every term needs to be accounted for, starting with your highest power. Here it's a squared. So you have to have x to the second power, x to the first power, and x to the 0 power. Anything to the first power of x is just something x. 1x, 5x, negative 7x. And anything to the x to the 0 power, well, anything to the 0 power is just 1, right? That means that's your constants column. Right, so this is, everything's accounted for here. We've got an x squared, an x to the first power, and an x to the 0 power. See, that's like x to the 1, and that's like x to the 0. Because x to the 0 is just 1. X to the first power is just x. So these are all algebra review topics right there. So make sure everything's accounted for. If it's not there, you must add it with a 0, like 0x. Okay. But everything's accounted for here, so we're all good. Now, this, we're dividing by x plus 5. So what we do is we look at the first term of each of these. I'm going to say, how many times can x go into 4x squared? Or you could say, what happens when I divide 4x squared by x? What is 4x squared divided by x? Or what if I take 1x out of this? What's left over? Let's look at it that way. 4x squared is just 2 times times x, right? That's your prime factorization. Okay, and I'm going to divide out of it an x, take out an x. What's left over? 2 times x, which is 4x. Everybody see that? So we're going to keep, everything stays in the proper column. Because x goes into 4x squared 4x times, that's what we write up here in our x column. Okay, so x goes into this first term 4x times. So up here we've got to put it in the 4x column. All right? So that's how we begin. That's your first step. Now what do? Just like regular long division, we're going to multiply everything. 4x times x is 4x squared. And then 4x times 5, and it goes in the, it's going to be 20x, so it's going to go in our x column, 20x, and it's positive. Everybody see that part? I'm going to keep this cleaned up as I go. Now we're going to subtract this whole term from the original. So 4x squared minus 4x squared is 0. That goes away. Now we've got 23x minus 20x. So that's going to leave us with a 3x. Okay? And we've done all of that. So now that we're finished, we're going to carry down our next term here, which is negative 16. And now we repeat the process. Okay? So I'm going to now say how many times does x go into 3x? Well, there's 3x and there's x. Take out what they share. What's left over? A 3. So that goes in our constants column. So plus 3. And now multiply them together. 3x. 3 times x is 3x. 3 times 5 is 15. Now subtract. And notice that I put parentheses around the whole binomial there because you're subtracting all of this. 3x minus 3x goes to 0. And then negative 16 minus 15 is negative 31. And there's nothing else. X does not go into that at all. It doesn't have an x there, right? So this becomes a remainder. So you're going to say remainder of negative 31. Okay? You will also see it, the remainder like this, negative 31 over x plus 5. I think I remember they did that in Algebra 1 like that. So far in the book, I've not seen them show the remainder like that. They're showing it like this. So your answer is 4x plus 3 with a remainder of negative 31. Is there any questions? That's long division of polynomials. Okay, and you should have done bukus of that, pages, at least one full assignment of these. And then you should have done a little bit more with it in another one, in Algebra 1. So you're going to have a lot of these tonight in your homework. Okay, you're going to work all the evens. So I'm ahead of myself here. Let's move on. I'm looking at the time. We've got 20 minutes. Okay. Let's do this next one. Do this on your whiteboards. So get them out. And we're going to write 3x squared minus 29x plus 56. And we're dividing it by x minus 7. All right. So now we're going to look at the first term. Our x. How many times does x go into 3x squared? If you can't see that, then do the 3x squared is 3 times x, and we've got an x, so we're taking out an x. What's left over? 3x. So x goes into 3x squared 3x times, so it goes in my x column. Now multiply them and subtract them. So 3x times x is 3x squared, stays in the x squared column. And 3x times negative 7 is negative 21x. Now put parentheses around them, and we've got to subtract it. So 3x squared minus 3x squared goes to 0. Negative 29x minus negative 21, so a minus and minus goes to plus. That's going to leave us with a negative 8x. And carry down your next term, plus 56. Okay, is everybody with me? Am I going too fast? All right, so Now repeat the process. Now we're going to look at x again. How many times does x go into negative 8x? It goes in negative 8 times. So negative 8. And multiply negative 8 times x is negative 8x. And negative 8 times negative 7 is a positive 56. Oh, wow. Looky here. What's going to happen when I subtract these? They all cancel out. Very good job. And it goes to 0. So there is 0 remainder. Remainder of 0. All right. So our answer becomes 3x minus 8. Let's see if I can make this prettier. 3x minus 8, remainder of 0. Now, if I just get this, what's in the box right here, for an answer, I am going to put a big fat X through it. I need to see all this work. I need to see that you can do this, okay? Any questions on this? So do you feel comfortable now that you've written through it? Let's see your boards. Make sure everybody worked through it. All but 2. All right. If you didn't have it, please go home and work with this video again and learn it. Okay, it's important. Now, there's an easier way to do this. What if I told you we can learn a little trick to do this using less paper and less time? Would you like that? Oh, we can't learn it just yet. We got to do problem 2 first. So, let's look at problem 2. Is x squared plus 1 a factor of 3x to the 4th minus 4x cubed plus 12x squared plus 5? Is it a factor? Well, we have to divide and see. If it's a factor, it would come out with a remainder of 0, right? Let's take this down to simple math. What if they say, is 3 a factor of 6? Well, what would you do? You would divide 3 into 6, right? Or let's make it a little harder. Is 3 a factor of 12? That was too basic. Is 3 a factor of 12? So you're going to go 3 into 12. Well, we know from our multiplication facts it is, but how do we prove it? Well, 3 goes into 12 4 times, right? And 4 times 3 is 12. And when you subtract them from each other, we get a remainder of 0. If there was anything other than 0 here, that means that 3 wouldn't have gone evenly. Let's do something like that. See, remainder of 0, 3 was a factor. Let's see, let's pick something 3 doesn't go into. How about 11? Is 3 a factor of 11? Let's see. 3 goes into 11 at most 3 times, which is 9. And when you subtract it, we have 2 left over. So it has a remainder of 2. 3 does not go evenly into 11 because it has a remainder, so it's not a factor. There's nothing I can multiply 3 by and get 11. Doesn't exist. Well, a whole number. So we say that that's not a factor. So this is the same thought process. Is if you end up with a remainder of 0, then x squared plus 1 is a factor. So let's see if we end up with a remainder of 0. So again, we're going to use long division, and I'm not going to go through this for time's sake, but when you do your long division, you end up with a remainder. How do you know to stop there? How did they know to stop at 4x minus 4? Well, look at your first power of what you're dividing by. Your leading term is an x squared. If your remaining binomial or problem down here, if its leading term is less than the leading term of what you're dividing by, it's not going to work. Because x squared doesn't go into x. X goes into x squared, but x squared doesn't go into x. So that's when you know, oh, stop, because it doesn't even go. I can't divide anything in there. So once the degree of your remainder is less than the degree of the divisor, you stop. So this is our remainder, 4x minus 4. That means it didn't go evenly, so it's not a factor. Okay? If this had gone in evenly and we'd ended up with a 0 at the end with no remainder, then you would say, yes, it's a factor. But because we had something left over, it doesn't go evenly. It's not a factor. Okay? Any questions about that one? All right. Okay, now I'm going to show you synthetic division. So this is problem 3. This is on your test, but you know, your test doesn't see if you use long division or synthetic division, but I think you're going to enjoy synthetic division, and you have to do this on your poster. Like I said, you're going to get one problem like this, and you're going to take your poster, divide it in half, and one side do your long division with that equation, and over here you're going to do the synthetic division. Okay, so let's learn how to do synthetic division. They say use synthetic division to divide x cubed minus 14x squared plus 51x minus 54 by x plus 2. What's the quotient and the remainder? So the first step is to look at what you're dividing by. Okay, x plus 2. And you want to reverse the sign on the plus 2. So that becomes a minus 2. And we're going to write, actually let me do it over here. I don't have it. Let me copy this onto a new page. Okay, here we go. So you look at what you're dividing by and look at that constant there, the plus 2. So flip the sign. So you're going to start with a negative 2. Right? That's your first step. Now draw this little symbol around it to show we're dividing. Okay? It's a different kind of division look, but it's all the same. We're still just dividing. Now this is synthetic division. I want you to write every coefficient, and if one was missing, like look at your form, make sure it's in standard form. So we've got a third power, second power, first power, and that's x to the 0. So they're all represented. So all we're going to do now is take all the coefficients. So this is a 1, this is a negative 14, a positive 51, and a negative 54. Okay? Now you're going to start by just dropping down the first term. Now multiply what you drop down by your divisor, negative 2. That's going to be a negative 2, and you write it right here in the next space. Okay, so now you're going to add these. So negative 14 plus negative 2 is a negative 16. Now repeat the process. Negative 2 times negative 16 is what? A positive 32. And now add them, and you get plus 83. Now repeat the process. Negative 2 times a positive 83 becomes negative 166. And now add them, and you're going to get a negative 220. Okay, so now that is almost the last step. Now we have to put it all back into an answer. So we know we're dividing by an x. We're dividing x cubed by an x, so we know it's going to begin with an x squared. So this becomes our x squared. So we've got 1x squared minus 16x plus 83 with the remainder of negative 220. And that's synthetic division. Okay. Let's work another one before I take questions. Okay, are you ready to move on? So work this on your whiteboards, and if you want to copy it on your notes, you can do that afterwards. Okay, it says use synthetic division to divide. The problem is x cubed minus 57x plus 56, and we're dividing by x minus 7. Okay, so what are we going to do first? We're dividing by x minus 7, so what number are we going to pull out of this? Positive 7. Flip the sign, and that's your first step. Now what's our next step? Write all of the coefficients. Yes. So good job. So what's our first coefficient we're going to write? 1. And next one? Negative 57. And the third one? Positive 56. There you go. Now, the next step is just to draw our line and drop down the first one. Whatever it is. If that was a 5, we would have dropped a 5. But remember, when you don't have a coefficient, it's just 1. So now we're going to multiply. 7 times 1 is 7. And now we're going to add them. So negative 57 plus a 7 is just a negative 50. And now repeat the process. 7 times negative 50. Well, 7 times 5 is 35. So add a 0, 350, and your negative sign, negative 350. And we're taking away from a negative 350, or we're adding to it a 56. So when you take away 50 of that, you're down to 300. Now take 6 more, and you're at 294. So negative 294. See, you didn't even need a calculator. So we're done. So what is our answer going to be? What term should it start with? Oh, wait. Do you see what error we made? We forgot to put a placeholder for x squared. So let's work it again. Okay. See, it was missing. So let me fix that. Little learning opportunity there. That even slipped by me. I haven't done this. I do it once a year. So I'm not above a little error here and there. All right. So we've got our x. We're missing our 0x squared. And what was the first term? I just erased it. It was just x cubed. So we're going to have x cubed plus 0x squared minus 57x plus 56. Right? So now let's repeat the process. You guys should be experts now. So actually, I'm just going to let you add it. Try not to look at mine. All right? And then in the end, come back and compare answers. Let's see if it makes a difference. I believe it's going to. I think I totally missed that in first hour. And we were rushing to get finished, and I was just trying to get that last problem in. So, first error, sorry. You got it now. So, did everybody get what I got? Hold your boards up and let me see that you did it. Beautiful. Beautiful. Good job. I saw everybody's board, but 2. So, please make sure you're doing your best. And if you're struggling, remember there's still tutoring. I think it's Mr. Osborne this week. It's the tutoring sheet's right up there. All right, let's look at the last thing. Ooh, we're out of here in 2 minutes. Okay, well, just look at this. This is nothing new. It's just now words. They want to know, what are the dimensions of the box? They tell us that the polynomial x cubed plus 7x squared minus 38x plus 240 expresses the volume in cubic inches for the shadow box. Well, look, they want to know what's the dimensions. They've already given us the length. We need the height. Okay, so you're just going to divide this polynomial by x plus 5, whatever method you want to use. Okay, and then that's all there is to it. I mean, you've got that. All right. Oh, they say use synthetic division to solve it. So you should follow the directions. I want you to work all the evens tonight, and you're going to have to do this on separate sheets of paper because there's not enough room on your worksheet. All right, any questions? Okay, work all the evens on 5-4. Thank you. This concludes our lesson.